Hello, and welcome to Business Continuity for your businesses running in Azure. My name is Vijay Tandrasisla, and I'm a program manager, part of the Azure Backup and Site Recovery team. I'm happy to see that a lot of customers taking the transformation of their digital IT to the next level using Azure. However, the impact of data loss in a digital transformation journey could be significant. Last year, when the ransomware WannaCry hit the hospitals in UK, there were a number of patients who were not able to access their records because of the WannaCry attack. So the impact of data loss could be on your business, it could impact your brand, as well as your career, because you, as the IT administrator, is responsible to make sure that there is no impact to your data loss. So today, I'm going to show you how Microsoft allows you to keep your businesses running continuously. If you think about business continuity, it's actually a spectrum. On the left-hand side, you have the high availability, for which you need to make sure your applications are running 24/7 and 365 days in a year. Secondly, if you have a regional outage, then you need a disaster recovery solution which fails over your application from one data center to another data center. And third, if you have a loss of data because of corruption, of a misconfiguration, or if you have a deployment challenge where you need to roll back your application, you also need backup. So it's critical that you have all three in your environment to make sure you have the right business continuity strategy. So what does Azure offer you? For a single VM, we offer the ability to keep your VMs running for 99.9% of the time. If you cluster your virtual machines, you can actually put them in an availability set and get a higher level of availability. Let's say you had an outage of your data center, but you still want your applications to be running seamlessly. Then you have the ability to turn on availability sets, which is a new capability that's available in preview. But let's say your entire region had a major catastrophic failure. Let's say there was an earthquake or a firestorm. Then you need to fail over your workloads from one region to another region. And for that, you have the Azure Site Recovery. So in today's presentation, we're going to talk about Azure Site Recovery and Azure Backup. So let me do a little bit of a demo to show you how Azure Site Recovery enables you to do a disaster recovery between two Azure regions. So here, I have the Azure portal, which has my virtual machine configured. Right down at the bottom, I have the ability to turn on disaster recovery, and this capability is in preview right now. So once I click on the Disaster Recovery tab, it presents me the option to specify the target region. Note that I can replicate my virtual machines to any region as I desire. So in this particular case, I have a virtual machine running in my Southeast Asia data center, and I'm replicating that data to East Asia. And then I can specify which resource group I want my virtual machine to fail over to. Also specify what's the availability set that I want to configure, and the virtual network to which the virtual machine must connect at the event of a failover. All of these configurations are automatically done as part of Azure Site Recovery, but you have the flexibility to specify any custom settings as you desire. So it's as simple as enabling replication for a single VM, right here from a single button. But let's say I've already configured disaster recovery, so here's how my dashboard looks like. Here I see that my virtual machine has been replicating successfully, and my replication status is healthy, and I'm getting an RPO of 1 minute, which means that the data loss tolerance that I'm able to achieve is I'll lose at most 1 minute of data if I do a failover to another region. Then it also shows me the settings. And if I drill down into my settings, I can see that I've configured my virtual machine to another region, and I've specified what my size of the virtual machine is. So in case the virtual machine is not available, the particular size is not available in that region, Azure Site Recovery automatically picks the right size for your virtual machines. And it also allows you to configure the virtual network to which you want to connect your virtual machine. But note that Azure Site Recovery is an active-passive configuration, which means that when you're actually performing the replication, you're not creating a virtual machine on the target site. You create the virtual machine only at the time of a failover. So if I want to do a failover, it's as easy as choosing the failover option. But if I want to do a test failover, which is actually a requirement for my scenarios where I want to perform DR compliance drills, I can choose test failover. Note that test failover is a non-invasive way of testing your DR drill, which means that while the replication is going on, you can still perform a test failover without disrupting your production or disrupting your replication. And more importantly, I can failover my virtual machines to an isolated network so that it does not disrupt my production virtual networks. So I can choose a target virtual network for my failover, and I can just choose that and go from there. So once I choose OK, I'm done, and I can let the test failover complete. Once the test failover is complete, I can check my application is running just fine. Once the application is working fine, I can stop my test failover drill. Now, imagine that I have an entire vault and I have a lot of virtual machines in my environment. So I can drill down into the recovery services vault that I've created. And here you see I have a number of virtual machines that are replicated. And it also shows me the virtual machines that are running successfully and the virtual machines that have a problem with it. So if I drill down into one of those virtual machines, it tells me exactly what is the issue that I'm running into and what are the corrective actions that I need to take in order to fix my replication health. Now, I also have the ability to drill down into the test failover status. So here I have a number of virtual machines that have been configured for ASR, but 9 of those virtual machines have never done a test failover recently, which means that you are not ready for DR compliance, right? So I can just walk up to this dashboard, click on the virtual machine that I want to do a test failover, and initiate a test failover right there from the UI. Not only that, I have the ability to monitor my entire network of my virtual machines. It gives me a topology diagram at the bottom. It shows me where my cache storage accounts are, where my target storage accounts are, where my site recovery vault is running from. And as you notice, this experience is not limited for just Azure IaaS VMs, but also have a very symmetric experience if I want to configure my VMware environment or a Hyper-V environment. But in this case, I have not configured VMware or Hyper-V because I am focused on providing the workload continuity for my IaaS workloads. I have not configured that. But then if I see, I have the entire setup of my virtual machines, my replication, my failover status, all available from a single vault, which I can manage my entire environment. But remember, many applications are not confined to virtual machines. Several times we come across workloads that have SQL Server databases or something like Azure's Active Directory. In those environments, we'd like to leverage the technologies that are natively available in all of these solutions. For example, in this particular scenario, I have a SharePoint HA farm, but notice at the bottom, I have a SQL Always On cluster with 2 nodes in it, one being a primary, second one being the replica, and the third node is acting as a witness node that is making sure that the application can fail over from primary to replica if the primary is down. Similarly, I might have application tiers and web tiers above that, and I might also have load balancers that are acting on top of these application tiers, so that if one instance of the application is down, the load balancer automatically routes my connections to the secondary node in my configuration. This is an example of a complex workload, and if I need to configure site recovery for this, I can do that right here from the same UI. So here, the application aware recovery, if you notice, the first step is to configure replication for my virtual machines that are not protected yet. But let's say I have my HA cluster of an Active Directory. I can turn on Active Directory replication, right? And that pretty much uses the native capability of Active Directory to do the replication. I do not need to use the virtual machine replication in this environment. Similarly, if I have a SQL Server always on environment, I can configure my replica to be on a DR site, and I can replicate my SQL environment from my primary to my replica. Once I'm done with that, I can do what is called a test drill or a test failover drill, where if the site is down, I can click the failover button, and I'll show that in a demo in just a minute. When I do the failover, what happens is the recovery plan that is created for this HA application can be triggered, and as part of the recovery plan, which I'm going to show you in a minute, I can do a failover of each tier of my application. So first, I can bring up my SQL workloads. Second, I can bring up my application tier, and then I can bring up my web tier. And then last but not least, if I have any load balancers, I can bring up all of those load balancers in a stacked manner. So here in this environment, I have the recovery plans defined. What a recovery plan is nothing but a scripted way of performing my failover if I have multiple steps involved in my failover. So here I have a SharePoint HA recovery plan created, and I can specify that I can go ahead and customize that recovery plan. And in this recovery plan, you can notice that I have several groups created. These groups enable me to perform failover in a staged fashion. So it makes sure that only when the step 1 on the group 1 is completed, that the next step in the second group actually starts taking place. So first, I have a script that performs the failover of my SQL availability set. Second, I perform the failover of my virtual machine, the app tier. And then once that is done, I can specify that I want to bring up the load balancer as part of my recovery plan. And the next step is to bring up the web virtual machines. Then the last step, I have the ability to bring up the load balancer associated with the web tier. And if you notice these scripts, if I drill down into these scripts, these are nothing but Azure automation steps that are pre-created, and as part of the specification, I can create an Azure automation account and specify what is the specific script that I want to run as part of my recovery plan. And with that, I have the entire failover scripted, and with a simple click of performing a test failover, I can initiate the failover of my entire SharePoint HA farm in just a few clicks. So if you notice that in the recovery plan I showed, you had the ability to failover an entire SharePoint farm. Notice that I have recovery plans not just with virtual machines, but I also have native replication of my SQL Server database, or if I have load balancers, I can specify custom scripts. For the convenience of the customers, we have added several of these Azure automation runbooks as part of the recovery plans, and these are available in GitHub. Last but not least, as part of your failover drill, very common questions that most customers have is, how do I make sure that my client is able to connect to the secondary site when the replication, the application failover from one region to another region? So you have two options right there. You can retain your IP addresses from your primary to secondary, right? So that you have the same IP address on your primary and secondary, no matter where the application is running on. The second option is to specify that you want to change your IP. Let's say you want to have a different IP address for your application on the secondary side. You can do that as well. And then coming to the client connectivity, how is the client able to connect to the primary or the secondary? Let's say the application IP address is different. Thankfully, we have the technology called Azure Traffic Manager, which allows you to specify two different URLs or endpoints as part of your Traffic Manager profile. And with the Traffic Manager, it'll try to connect to the primary site if the primary is available. And if it's not able to respond to the ping request for the Traffic Manager, it'll automatically redirect your calls to the secondary site. So this is something that's natively available in Azure. So all you have to do is create a new Azure Traffic Manager profile and specify the two URLs you want to connect to. With that, you are now able to connect your client application, maybe running on premises, to your primary site or to your secondary site. That's your choice. The last but not least is failback. So many customers ask the question about, hey, I've done the failover, but how do I make sure I can bring the application back to the primary site? It's actually quite simple. Let me show you how. So now if I go to the virtual machines, let me go drill down into the replicated items. Replicated items, I have a virtual machine that has failed over to the secondary site. All I need to do is right-click and specify reprotect. When I perform a reprotect, what it does is sets up replication in the reverse direction, so from the secondary site to the primary site. And the key thing to note is, if the primary site is still available and the data is still available, the replication of Azure Site Recovery only sends the deltas from the secondary back to the primary site. Once the reprotection is enabled, you can fail over back to the primary site and get your application running back on the primary site. It's actually a two-step process. So you fail over, reprotect, and fail over. So let me just summarize what you just saw with Azure Site Recovery and IaaS VMs. It's a no DR infrastructure solution, and it has the ability to perform automated protection and replication with the help of recovery plans. It gives you the best RPO. As you just saw, we do continuous replication every 5 minutes, and you just saw on the UI that we were getting a RPO of 1 minute. And you also have the best-in-class RTO. The reason you have a good RTO is because you are creating a recovery plan, and as part of the recovery plan, you have exact steps that you need to perform, and so you can cut down any manual processes and pretty much automate your recovery plan. You can also perform a no-impact DR drill. I showed you the ability for test failover, which is non-invasive, non-disruptive, which means your production can still continue to work. Your replication is on, but you can still perform your test failover. You also saw the ability to centrally monitor all of your replication and your test failover health from the Azure Site Recovery dashboard, which is the Recovery Services Vault. You can perform an orchestrated recovery using a recovery plan. And last but not least, you have the ability to do a failback from your secondary site to primary site with just 2 clicks. The capability for Azure Site Recovery DR for your IaaS workloads is currently in public preview. And here is a screen which shows you all the capabilities that we have enabled as part of the Azure Site Recovery IaaS DR. Now, this capability is also available globally across several regions in Azure, and we are constantly increasing our capacity and expanding to more regions as we expand the entire Azure footprint. Now, let me switch to Azure Backup. We talked about DR, let me talk about Azure Backup. In terms of Azure Backup, a lot of customers start their journey for Azure Backup in sort of 2 ways. First thing is they look at backup or Azure as a storage target. So with the journey of digital transformation, they start creating their workloads on premises, but saving their backups in an offsite location in Azure as a storage target. This is completely and 100% supported by Azure. Second scenario is that customers move their workloads directly into Azure and want to protect their workloads in Azure using some kind of technology. Again, there are several traditional software solutions that are out there that allows you to perform backup of your workloads running in Azure IaaS. So these are two capabilities that are already available through DPM as well as several third-party solutions out there in the market. But one of the things that we look at as a very key differentiator with respect to Azure Backup is the ability to perform these two sort of scenarios, whether it is backup from on-prem to cloud or protecting your Azure workloads, is to do that without having any infrastructure in your environment. So what that means to you? So if you think about your application architecture, you may have your virtual machines, you may have SQL Server databases, or you may be using several of the PaaS services running in Azure, like Azure Files. So you, as the IT administrator, is responsible to increase the footprint of your application, scale that, and deploy more stamps of your application. While you do that, the Azure technology should be able to scale without you thinking about the scale for Azure Backup. So with Azure Backup, we take care of scaling the storage that you need, scaling the application job scheduling, taking care of the garbage collection processes, creating incremental backups without having to require any infrastructure. So that while you focus on scaling your application, we're able to scale our infrastructure, the Azure Backup infrastructure, not just for one customer, but for N customers. And this gives you the ability to have an enterprise-wide scale. At the same time, you have the ability with no infrastructure to back up without any infrastructure needed. So what's the benefit here? Obviously, you have the ability to not deploy any infrastructure, so there's complete freedom. You do not need any agents, you do not need any servers, you do not need to deploy any sort of backup VMs. Second, it allows you to have the leverage the economy of scale. For instance, as you increase your virtual machine capacity, the backup infrastructure automatically scales, and you just pay for what you use. In case of traditional backup solutions, if you scale your applications, you may need to increase the capacity of your virtual machine. And if you do not use the entire capacity of your virtual machine, you're paying for compute that you're not going to use. But in case of Azure Backup, because the infrastructure is taken care of by the service, it's a complete PaaS service, you do not need to worry about that. Another key thing that we've noticed with a lot of large enterprise customers is that while they move their workloads to cloud, we also notice that the what we call as the role of the application admin is now significant. So the application admins are now much more empowered than in the traditional world, which means that they can enable self-service backup, they can perform self-service restore. There is no need for a IT admin to provision storage, manage that, and perform any of those IT operations. And pretty much the application admin can perform all of his application management, backup, restore on his own. And what this means for the IT admins is that the IT admins can graduate to a higher level function where they are now focused on governance, cost control, and making sure that the entire infrastructure is compliant, rather than focusing on day-to-day operations of backup. So this is a key differentiator and a fundamental shift in how we think about backup as you move your workloads to cloud. So let me start with the demo of how to enable Azure VM Backup. So here I have a very similar experience like Azure Site Recovery. If I walk up to a virtual machine, I have the ability to turn on backup right here in the VM settings blade. And here, all I need to do is to specify whether I want to use the existing vault to back up all my virtual machines, or I want to create a new vault. And then secondly, I need to specify the backup policy. Backup policy defines two things. One is the schedule of your backups. Second is your retention range. With IaaS VMs, we have the ability to not just retain your backups for short term, but you can even retain them for several years, like 7 years or 10 years with the Azure Backup policy. So here I have the ability to create a new backup policy. I can specify the policy name. It's a test policy, let's say. And I can specify the schedule I want the backups to be. And I can retain my backups not just for a few days, but I can retain them for several months. Let's say I want to retain that for 60 months. I can do that right here from the backup policy UI. Once the backups are enabled, let me just show you an instance of a virtual machine that's enabled for backup. Here I see the UI that allows me to look at all the recovery points that are pertinent to that VM. I can even perform ad hoc VM backup. Let's say I've done my application rollout, but before I do the application rollout, I want to do an ad hoc backup. I can do that from right here. I can perform a restore. I could do two kinds of restore, either restore the entire virtual machine or restore specific disks. I could even do a file recovery. A file recovery is an important and interesting feature which allows you to perform restore of individual files from a virtual machine. I'll show you a demo a little later. And then here I have all the the recovery points showing here. And one of the new capability that we have previewed is the ability to retain snapshots in the customer storage account. What this allows you to do is to perform a very fast backup and recovery from the data that's already there in the customer storage account. This way, the data is retained in the customer storage account for 7 days, and then we will also replicate that data to the vault so that even if the production virtual machine is deleted or destroyed, you have a copy of the data in the vault, and the vault data can be retained for several years. So as you may wonder whether the VM backup is only for Windows virtual machines, the answer is no. We support both Windows virtual machines and Linux virtual machines. And more importantly, with Linux, we also added the ability to perform application consistent backups for your Linux virtual machines. How is that possible? You may wonder how. In Windows, you have the ability to quiesce your workloads using the VSS service. But in Linux, you need to quiesce your workloads, but you have the ability to specify a pre-script and a post-script. And the pre-script, what it does is allows the customer or the application vendor to specify how he wants to quiesce his workloads. So in case of MySQL, he could take MySQL dumps before we perform the VM snapshots. And once the dumps are taken, he can delete them. Or if you have an application where you need to quiesce your workloads, let's say you want to freeze your application I/O, you can do that. Then we can take the VM snapshots, and when that is done, we can perform the postscript. Okay? So this allows an application to be run in a application consistent mode with the backups all application consistent. Let me just show you how this is done. So here I have a JSON file which is stored in my etc Azure folder inside my virtual machine. And in that particular script, I can specify what I want to do as part of my pre-script. So in this particular example, I am using MySQL database and I'm quiescing my MySQL database and taking a database dump before I take the VM snapshots. And once I have specified that, I can just go back to my demo. I'll show you how I can perform a restore here. So I've logged on to my Linux environment here, and I have logged on to the as an administrator, and I'm connected to the Azure cloud to my demo subscription. So here I can see that I'm using the Azure CLI, which is a command line interface available for customers using either Windows or Linux. And I'm performing a list of all the Azure Backup vaults. And here I have several vaults as part of my configuration. But I don't need to look at the entire vaults. All I need is the ability to perform a restore of a single file. So for that, what I can do is perform a restore action, and I can specify that I want to mount the RP. What mount RP does, I'll explain that in a minute, and then I can specify the specific virtual machine, which is called the container name, and then I can also specify the recovery point name as part of my restore operation. Let the restore operation kick off. While that is going on, let me explain how this works. So as part of my Azure Backup, my data is stored in the vault or as snapshots. But what we're doing here is presenting this recovery point as an iSCSI target. Once I have an iSCSI target, now I'm downloading a script which allows me to connect from my client machine, that laptop right here, to my iSCSI target that is running in the cloud. Let me do that. So the benefit of this approach, I need to give a password here. The benefit of this approach is that since I'm directly connecting my laptop or my client machine to the Azure cloud, I'm not restoring or downloading my entire recovery point of my entire virtual machine. I can simply browse what files are part of that recovery point, and I could restore exactly the files that I need. So in this particular case, since I have my MySQL database dumps, I can take one of those dump files and restore it back onto my MySQL environment. I do not need to download my entire virtual machine from cloud to on-premises. So this may be just a few meg or a few gig. So all my files are right here as part of this backup. So this is mounting my recovery point as part of a local volume on my machine. So if I do a dir, it shows me all the files that are part of my recovery point, and I could, change to any folder here. And if I have any file that is interesting as part of this backup, and I could copy any one single file or set of files from this recovery point onto my production environment without downloading the entire virtual machine. So here we talked about backing up virtual machines, whether it's Windows or Linux virtual machines. How about encryption? As part of best practices in Azure, we recommend that all customers turn on Azure Disk Encryption. This allows the Azure virtual machine to be encrypted using the BitLocker keys, and with that, your virtual machine is encrypted. Not only that your virtual machine is encrypted, but also your backups are encrypted as part of that. And by default, the vault is also using a storage account that is encrypted with the storage side encryption. So you have complete encryption end-to-end with backup and IaaS VMs. But the key thing I want you to take away here is not only are we storing the disk data as part of the virtual machine backup, but we're also storing the configuration and all of your the key material or the key information needed to restore your virtual machine to a particular point in time. If you keep your backups for like N years, you always know that you have the ability to roll over your keys as part of your best practices in your enterprise IT. But if you need to restore to a particular point in time, you need to make sure that not only is your data consistent to that point in time, but also your key material is also consistent to that point in time. With Azure Backup, you can be rest assured because we keep the particular key material, the version of that key when it was at that point in time as part of the backup. So when we restore, we can get you back to the same exact point in time with respect to the VHDs, configuration, and your key material. Okay, so we talked about virtual machines, but what about if I have a database or something that is running inside a virtual machine? You saw the demo where I could restore a MySQL database from my virtual machine. But if I have something native, let's say a SQL server that is part of my virtual machine, we have the ability to back up your a SQL Server inside your IaaS VM as well. Let me show you how. So as part of configuration, I go to plus backup in my recovery services vault, and you notice that I have the option to choose virtual machines, or if I have a SQL Server inside an IaaS VM, I could choose that as well. And in case of SQL Server, it's a two-step process, because first you pick the virtual machine you want that has SQL Server in it. Second, it also needs to discover what are the specific databases that are part of that virtual machine. Because sometimes, believe it or not, you do not want to back up all your databases. There may be databases that are temporary. There are databases that are critical to your business. So you want to back up your databases that are critical to your business. So you have the capability to specify exact set of databases that you want as part of the backup. So this discovery process going through, there are no virtual machines here, which means that all my virtual machines are already discovered. I can go to the configure tab, and here there are two virtual machines that are waiting to be backed up. And as I told you, you can drill down and see what databases are there as part of my virtual machine. So it has done a second level inquiry into my virtual machine to find out what are the databases that are connected to this virtual machine. So let's say I want to back up my MSDB. And as part of my backup specification, the policy specification, in the case of virtual machine, you are allowed to back up once every day. But in case of SQL, you can choose full backups, you can perform differential backups, or you can even perform log backups, and you can specify a much tighter RPO of say 15 minutes. So every 15 minutes, we'll create a log backup and transfer that to the vault. And you can specify different retention periods for your log backups and your full backups as part of your backup policy specification. And once I'm done with that, I can choose that I want a SQL compression to be turned on, which means that if I have a large database with the SQL backup encryption, which is natively available in SQL, I'm getting a much better a compression of data on my target storage, and I can say OK, and that's about it. So I can enable backup. I can choose a virtual machine and specify specific databases as part of my backup enablement. Similarly, let me just show you how I can do Azure File Share Backup as well. So in Azure File Share Backup, first thing I need to do is look for the storage accounts that are part of my Azure subscription. So I pick my Azure storage account that I need to back up. And here I have some file shares as part of that storage account that I can choose. And again, I have a backup policy. So this capability was just announced a couple of days ago in February. And we have the ability to back up, retain your backups for like 120 days. And as part of the broad availability, we'll increase the retention range for a much higher value. That's as simple as that. So you walk up to the UI, you can specify your virtual machine or your SQL database or your file share that you want to back up, specify the backup policy, and off you go. So here I have configured several backup items here, and I have 4 SQL databases. I have 3 file shares, 1 virtual machine, and some backups coming from on-premises using the Azure Backup Agent and Azure Backup Server. Let's say I want to restore a database. I can drill down to the database backups. I can perform a restore. As part of restore, I can create a copy of the restored database, or if I have a corruption and I want to rectify that corruption, I can specify override. And here it allows me to choose whether I want to restore a full backup or a log backup. the log backups, as you see, we have been doing continuous 15-minute log backups. So you can specify an exact point in time that you want to restore your database to and choose OK. And then it gives me the option to perform a further recovery, or do I want to stop the recovery after I'm done with this process, right? So with that, I can restore my databases to a particular point in time. Similarly, I have the Azure Files server. Let me just drill down to that. And I could either perform a full share recovery or a individual file recovery. For full share recovery, I can drill down, specify the particular recovery point I have, and then specify that I want original storage location or an alternate location. In case of original storage location, I can choose whether I want to overwrite the existing files or skip them. It's as simple as that. So you walk up to the UI, walk up to the particular file share and perform your restores. And same thing with databases or virtual machines. So what did you just see here? So with all of these configurations, whether it's virtual machines, SQL servers, Azure files, you have the exact same experience where you have no infrastructure that you need to deploy as part of your backup. Your cost, it's actually a very low cost solution or a cost effective solution because you do not need to deploy any infrastructure to perform your backup. You just specify the intent and pretty much the backup service takes care of all of the plumbing needed for you. It provides central management. As you saw that inside my vault I have several set of applications that I want to perform backup, whether it's SQL servers, virtual machines, all in one place. Last but not least, it also has the ability to store my backups for not just for short term, but as well as my long term retention. So you may be wondering, how do I perform monitoring if I want to monitor my entire infrastructure, whether I have virtual machines in a single vault, if I have multiple vaults or several subscriptions, I could do that. It's actually quite simple. I can walk up to the same portal here, and under the Backup Reports tab, I have a specification of my diagnostic settings. So once I drill down into the diagnostic settings, I can send all my monitoring data, the backup jobs, the schedules, all of the metadata about my backup infrastructure can be sent to a storage account where I can perform further analysis, or I could send it to Log Analytics. With Log Analytics, if I have an existing workspace, I could send all of this data to an existing workspace, or if I want, I could create a new workspace and send all of this data there. And within the Log Analytics workspace, I can perform joins using my Kusto KQL queries, joining the data from different vaults across different subscriptions, and have a single dashboard to monitor all my backup operations. But let's say I want to do trending of my data and I want to perform, see how my backups are working for the last 3 months. I might be using something much more sophisticated. Let's say I want to send my reports to my CTO. So in that case, I could turn on something called as Azure Backup Reports. And this reports, what you do is simply send all of this monitoring data to an Azure storage account. Once you send all of this data to Azure storage account, you can sign up to Power BI. And Power BI is a free tool that allows you to suck all of this data from the Azure storage account. And what we've done is created a Azure Content Pack, which allows you to suck all of that data from your Azure storage account into the Power BI account and perform all of these reports. So here I've already done that previously, and here is a dashboard that I've created, which is a default dashboard that comes as part of the Azure Backup Content Pack, which shows me the number of protected instances, how much cloud storage I'm using, how many active alerts are there, how many backup items are there, what is the distribution of my cloud storage across my workloads, across the GRS and LRS various redundancy options that I have, and shows me all the alerts, where are the alerts happening, And then I can drill down into each of these specific tabs like storage, backup items, job health, and job duration. If I want to customize my report, I can do that too. So here I could create a new tab, and let's say I want to trend my storage over a period of time. Okay, so here I have my cloud storage, but let's say I want to see this trending over a period of time. So here it shows me that my storage has gone up from September to October. So this kind of trend analysis can be performed as part of your Azure Backup reports. And the best part is, since this is sucking data from multiple storage accounts, it's a one consolidated report across your subscriptions. Secondly, the entire schema for your the Azure Backup reports are readily available. So you can pretty much drag and drop any piece of information that you need. And last but not least, it has some very useful aggregations as part of this. For example, it has a count of all the backup items or the sum of all the storage used. All of these aggregations are pre-created for you so that you do not need to calculate how much backup items you have across your entire environment. So that's the way you create a Azure Backup Power BI report. So you push all of the data to Azure Storage account. Once you've sent that data to Azure Storage account, you can push all of that data to the Power BI reports. And the Power BI reports have built-in reports, or you can customize them. And again, the benefit is there's no infrastructure you need to deploy. There is no, you can perform all of these operations across your subscriptions and across your vaults, and you can even customize them as per your needs. So here are a summary of all the capabilities we've added over the last year. And some of them that I showed just now, like the SQL Server and ISVM Azure files, these are currently in preview. And then we have an exciting roadmap of capabilities in the next 3 to 6 months. With that, I'm going to end the presentation. Thank you, and hope you have a good day.